Welcome, guys. It is hard to believe because I have not seen you in so long. I do miss seeing your bright and shining faces in class. Maybe not shining, I don't know, because of the masks, but what have you. This is our last section of Chapter 3. Hard to believe because you haven't been here in person, but we are going to conclude Chapter 3 with a 3.5. Now, 3.5 will be a little different than the other four sections. My guess is the other four hopefully were fairly simple. Should be a combination of what you've known in the past about inequalities and what we learned in chapter 2. But this part might be new to you. You see, in 3.5, we're going to talk about compound inequalities. Now, what's a compound inequality? Please do write this definition down in your notes. Again, the disclaimer is always, please write down anything you see on the smartboard into your notebook. This will help you reference it during the homework problems. So what is a compound inequality? Pause the video, write down the definition, and I'll explain it. Okay, now that you've paused it, what is a compound inequality? It is two inequalities that are joined by the word and or the word or. They are special types of inequalities. Again, two categories we're talking about today. An inequality joined by the word and, or you can have an inequality joined by the word or. We are first going to examine what it looks like to have an and inequality, and then we will get into or inequalities. So inequalities using and, what do we imagine by this? Well, as we've been talking, inequalities are solution sets to problems, right? We're not going to typically have x equals 7. It's going to be stuff like x is greater than or equal to 8. But what if we have a special situation where x is greater than or equal to 8 and x is less than or equal to 50? What do we do in that case? What if, what's a real world situation you could analyze this? Let's talk, what if we were to describe in the situation, x is the variable of how much a student weighs in Van Buren High School? Maybe we have someone who's very small. Everyone at a minimum weighs 100 pounds, let's just say that. And then we have some big football players or wrestlers, and our biggest person weighs 300 pounds. We would use an and inequality to describe the situation of their weights, right? Everyone weighs at least 100 pounds, but no one weighs over 300 pounds. Both situations are occurring. So how would we write this? How would we write this and inequality? Well, just as you imagine, you're going to bring this, we're going to have an x in the middle, right? That's our variable. And then on one hand, you're going to work your way across. Remember, the open side of the inequality always faces what's largest. You're going to have two inequalities here for the and inequality. Now you'll notice this right one, I'll point to it with the blue arrow. The one with the blue arrow, the x is facing the open side, right? So x is the larger quantity. Well, what does that mean? Well, that means the 100, since x is greater than or equal to 100, is going to work its way down here. Consequently, we also have this inequality where x is on the smaller end. All of the values that we could plug in for x are going to be less than or equal to some number. And we notice, right, x is less than or equal to 300. 300 is on the large end. This is how we write and inequalities. Let me give you another example. If x is greater than -5 and x is less than 7, we would write that as a compound inequality by saying 7 is greater than x is greater than -5. With the and inequality, you can imagine x is smushed in the middle. Okay? So the question then begs, we've given two examples here. What would this look like on the number line? Well, let me show you. So we've got our two inequalities here. I'll erase them temporarily, but I'll rewrite them up here. Let's continue with that example. X is less than 7, but is greater than -5. What would that look like on the number line? Well, If I draw a number line out here, and let's say I start at 8, 7, 6, 5. Again, please draw your own number line on the paper. If I'm moving a little too quickly, please pause the video. Throw in one more data value. So I've got a number line ranging from -6 to 8. How does the and inequality work? Well, instead of 1 point of interest, you now have 2 points of interest. As you can imagine, they are -5 and 7. Both are points of interest. It's just like we did in 3.1 with graphing number lines. You just simply need to do it twice. So for -5, let's look at it. Well, x is greater than -5. The open side is facing the x. Therefore, we are going to move to the right of the -5. If we look at if we look at the 7, we have the opposite situation. The open side's facing the 7. So we will move to the left of 7. And what these end up looking like is what I think is the front of a Jeep. But essentially, you end up with 2 data points and a line in the middle. Your hint for and inequalities. The graph, and I do want you writing this down, the graph will always be 2 points with a line down the middle. 2 points with a line down the middle. And that's for the graph for and inequalities. Again, this is all about ands. You don't have to write this part down, though, with the caret. But if you forgot, the graph for and inequalities will always be 2 points with a line down the middle of the two. Okay, let's try another example. I'm going to give you a graph, and I'm going to give you a inequality, and I want you to do the opposite. So here I'm going to give you a graph. And I want you to come up with the inequality. And then over here, I'm going to give you the inequality. And you are going to come up with the graph. So pause the video right now, figure out the inequality for the red graph, and then come up with the inequality, or come up with a graph for the green inequality. Okay, so you've now done that. Let's check your work. Well, when I look at this, if I'm going to go from the graph to the inequality, I'm going to start by identifying my 2 points of interest. I know that there's a line in between 2 points, so it's some form of and inequality. So x is going to sit right in the middle. Again, I can tell because it's 2 points with a line connecting them. So then what am I going to do from there? Well, I'm going to identify my points of interest. I'm going to identify 2 is one of the ends, and -1 is the other end. Now, which end will they go at? Well, I can see that I'm increasing from -1. In other words, the values for x are greater than -1. But all the values for x are less than 2. So that's how I figure out my ends. Final step here, determine if which or any have an equal to sign. I notice the circle for -1 is filled in, but it is not for 2. That will be your solution. So again, the different steps you're looking at. Is it an and inequality? Well, yes, there's a line connecting 2 points. And we identify our points of interest. Finally, identify whether it's an equal to or not. For the graph creation, you should have come up with something similar to the following graph. Identify my points of interest, 7 and 9. Again, it's an and inequality, so I have a line connecting the two. I also could view it as I know x's values have to be greater than 7, so moving to the right from 7. But they have to be less than 9, so I'm moving to the left of 9. And finally, I'm going to fill in my circle at 9. because there is an equal to, but not do that at 7. So rough overview of how we create graphs for and inequalities. Now let's move on to solving some equations. So how does solving equations work? This is what inequalities work. Again, this is just an overview of compound inequalities, but what does it look like when we have an algebraic compound inequality? Well, I'll talk you through one, and then I'll have you try one on your own. So let's say we have -4 is less than r minus 5 is greater or less than or equal to -1. -4 is less than r minus 5 is less than or equal to -1. Well, and when you think and, you should be thinking multiple. You should think both. We've got this r minus 5 sitting in the middle. Now, what we've been doing since chapter 2 is getting the variable by itself. So what do I mean by get the variable by itself? I mean, that variable needs to be alone in the middle. We want our solution to look something like this, where the variable is alone in the middle. So just like we've been doing, look at the variable and see what's preventing it from being alone. I identify that this -5 is standing in the way of the variable being alone. Your chapter 2 brain should tell you, well, the opposite of r minus 5 is plus 5. But the question becomes, do I add the 5 to the -4 or to the -1? Well, the answer is, because we're doing an and inequality, you're actually going to add 5 to both. Again, the common mistakes here, some people forget to add 5 to one of the ends. Some people will try and add 4. You always want to work from the middle out. Okay, get that variable alone in the middle. That doesn't mean I'm getting rid of any of the ends. Just get that variable by itself in the middle. So -5 plus 5 will cancel. I know that -1 plus 5 is 4. R is again by itself now in the middle, happily. And -4 plus 5 is 1. Therefore, the solution to my compound inequality would be any value for r between 4 and 1. If you would like to test this, pick a value in between like 3, plug it back into the original, and see if it makes it true. Again, if we do this, I know I need some value. When I plug 3 in, 3 minus 5 is -2. Is that -2 between -1 and 4? Yes, it is. And thus we have our answer. So to summarize, what are the steps? What are you thinking of while we're doing this? Number 1, we want to get the variable by itself. That does not mean get rid of one of the ends. That does not mean do something to one side and not the other. Rather, it means get whatever is attached to the variable out of the middle and put it on both ends. Okay, so here's an example for you to try. Let's solve -7 is less than or equal to 2x minus 1 is less than 15. Okay, pause the video right now and see if you can solve this on your own. Okay, so you've hopefully attempted it. Again, our goal should be, how can I get x by itself? Again, I am not adding 7 here. No, that is not what I want to do. Nothing with the ends. I'm trying to get x alone in the middle. So what's attached? Well, I've got the -1 and the 2. The 2 is multiplied by x. The -1 is subtracted from the 2x. What do we handle first? Well, your chapter 2 brain should tell you adding 1 is the first step before handling that 2. Now remember, I must add 1 not to one side, but to both. When I add 1 to every single side, -7 plus 1 is -6. In the middle, I have 2x. And on the end, I have 16. I'm going to do the same thing, except I want to get rid of the 2. How is the 2 attached to the x? Multiplication. Divide all sides by 2. All sides by 2. Leaves me with -3 is less than or equal to x is less than 8. And this will be my solution. Again, how can you test this? Plug your answer back in the original inequality. Okay, this is and inequalities. If you are struggling with and inequalities, pause the video at this point. Email me any questions. If you would like a break in the video, pause the video, go try some of 3.5 homework, anything with an and inequality, and see if you can figure it out. For now, though, if you would like to keep plugging along, we're going to move on to or inequalities. If you need to take a break, this is a good opportunity to do it. Okay, you're back here. We're going to finish up. We're going to talk about or inequalities. Or inequalities. So what happens with or inequalities? Well, or inequalities are the opposite. What if I have a situation where x is less than -3 or x has to be greater than 7? What's a good example of this? Think about when you go to a restaurant. You either get a discount if you are a child under 12 or a senior citizen above the age of 60. How would we write this as an inequality? Well, yeah, kids under 12 get a discount, but also, or if you are over 60, you also get a discount. And if it included people age 12 or age 60, we'd add an equal to. You see, the and inequality and the or inequality are opposite. While the and inequality is shoving the variable in the middle, the or inequality is looking at the opposite ends of the spectrum. So what do the graphs look like? Well, remember, and or inequalities are opposite. If you can imagine a number line here, our and inequalities look something like this. 2 dots with a line in the middle. Our or inequalities are the opposite. So this is an and inequality. Our or inequalities will look exactly opposite. They will have 2 dots, but they will shoot off in opposite directions. They will not meet in the middle. How can you imagine this? Well, let's try and graph our first inequality here. Again, do it the same way you've always done. We've got a number line. Again, please write this down on your paper. And my first step is I'm going to identify my points of interest. Well, now I have 2. I've got one at 7, and I've got one at -3. But look at the way the signs are. With the -3, the open side is facing the negative. When the open side faces the -3 away from the variable, that means I need to go left. We learned about this in 3.1. If the open side is facing the variable on the 7, that means I need to go to the right. Again, your or inequalities will look exactly opposite of your and inequalities. Okay, this is how we graph an or inequality. So the question becomes, how do I solve an or inequality if it's in a compound, or if it's a compound, or if it's in an algebraic situation? Well, what if we have 4b plus 3 is less than -5, or -2b plus 7 is less than 1. Now, and inequalities, remember, what did we talk about? What we do to the middle, we do to both sides. We tried to get the variable in the middle alone. That was for and inequalities. Or inequalities are much simpler. It's just like doing 2 problems. It's like a wall is here, and we're going to solve them completely separately. They don't exist together. The and, we're all happy together and in the middle. The or, we're completely divided. Just solve the 2 separate. So if I want to solve this first inequality, what am I going to do? Well, it's just like 3.2. Subtract 3 from both sides. I get 4b is less than -8. From there, I divide by 4. And I get v is less than -2. Now I'm going to jump to the other side of the wall and solve the other inequality. Subtract 7 from both sides. I have -2b is less than -6 at this point. And I'm going to divide both sides by -2. When I divide both sides by -2, what happens? Well, the sign flips. I get v is greater than 3. So I've solved my two inequalities separate. Now you just toss the word or in the middle. So what's my solution? V is either less than -2 or v is greater than 3. Again, how do you know if you've done it right? Well, as always, you could plug some solutions back into the original and see if it makes them true. Okay? Any number less than -2 or larger than 3 should make these inequalities work. Okay? Any number less than -2 or greater than 3 should make these work. Okay? So now where are we going from here? Well, we need to create a graph. Okay, we're going to graph these inequalities. So how does this look? Well, I'm going to draw that number line. And then I'm going to place my dots, my points of interest. And then from there, I will shoot off to the right. And I will shoot off to the left. Again, leaving those circles open because they are not an equal to. Okay? And or inequality. I hope this lesson has made it a little clear about compound inequalities. Again, this is probably the most difficult lesson of Chapter 3 just because this stuff is new. So if you have any questions, feel free to reach out. Let me know how I can help. I know we covered a lot here. Best of luck to you as you solve the practice, and keep me posted.